Hey, so today we're going to be talking about simplifying radicals. Now, radicals are anything that has this little signal, this little mathematical symbol in it. It is a radical sign. It's radical. So the actual little check mark is the radical sign. Anything underneath it is called the radicand. Kind of crazy. And then this tiny little number over here is called the index. So it's important to understand how, when you're simplifying radicals, what each part of the radical is and what it means. So actually the radical sign, anything underneath, even if there was letters or numbers or whatever, any of it is called the radicand underneath. And then the tiny little number is called the index. Normally, square root functions root functions look like this. The square root function, which what's really there if there's no number is an imaginary 2. So the index is really 2 when there's nothing written there, and we just assume it's a 2. And we know that the square root of 64 is 8. Here, the index is 5, the radicand 752. Here, the index is 3, the radicand's 216. So it's kind of how they work. What all the aspects are to it. And now I want to explain how you break these bad babies down. So there's a few ways, but I think the best way is just building factor trees. So you can break down 48 in any way you know how. If you think, when you look at 48, you say, oh, 2 and 24. Go ahead and do that. When I do it, I think of 6 and 8. And then you break down factor trees as far as they can go, all the way to prime numbers. So 6 can keep breaking down because 2 times 3 makes 6. And then 2 and 3 are prime numbers. I've totally broken down that side. This guy goes to 2 and 4. That's what I just immediately think of. It could also do 8 and 1. That would also work. And then you have to break down any other pieces that could continue to break down. So now I've gotten everything into prime numbers. Now what you do with that is really awesome. The little index number, so in this case would be a 2 when nothing's written there. There's a 2. That is how many you need of one number to be able to pull out. That's how many you need to be able to pull out. I need 2 of something to be able to pull one of them out. It's like they are in jail when they're in the radical sign. And you need 2 of them because one of them is going to hoist the other one out. Something, I don't know. So you need 2 of something to be able to pull one out. We have this pair, so I can pull out 1, 2 out of the radical. We also have this pair of 2 2s, so I can pull out another 2. And you multiply it when you pull it out. All that's left in underneath the radical is that 3. So 4 root 3. You just multiply any of the numbers you took out. 4 root 3 is the simplified radical of root 48. So this would be your final answer. Now, just to hit home on some concepts, I should have done this before I started it, that when I have 48 and I've broken them down into these prime numbers, just to show you, 2 times 3 times 2 times 2 times 2, 2 times 3 times 2 times 2 times 2 equals 48. So when you break it down into factors, that's why it's equivalent, because all of these multiplied together get 48. And then you need the index of something to be able to pull one out. So 2 in this case, 2 is something to be able to pull one out, 4 root 3. Now check this out. We have the original problem, square root of 48. And then we have our answer, 4 root 3. And they're the same decimal because they're equivalent. And we crushed it. All right, let's do more. So you build factor trees. This index, when there's nothing written, there's a 2 right there. When you break down 72 any way that you know how. So I'm going to do 8 and 9. The 9 is 3 and 3. 8 is 4 and 2. I can break down 4 further, 2 and 2. Usually, the prime numbers they usually break down to are 2s, 3s, 5s. Prime numbers, 7. They can't break down anymore. That's a prime number. So I need 2 of something to be able to pull 1 out. So I have 2 2s right here. Can pull out a 2. I have 2 3s right here. I can pull out a 3. And you multiply when you pull it out. The only thing that's left in is that 2. So he stays underneath the radical. 2 times 3, 6 root 2. That would be your final answer. And if I type in the calculator root 72 and I type in the calculator 6 root 2, these will be the same ugly decimal. Oh my gosh. Now we're going to do it where the index is a little bit higher, where the index is 3 now. I had to put something on here so it won't move. So now I need 3 of something to be able to pull 1 out. So there's anything you can think of. I actually think of, when I'm thinking of 96, that 6 times 16 makes 96. And then I can break down that to be 2 and 3. 16 will go 4 and 4. And you could also do 8 and 2. And then break these guys down, 2 and 2. So I've broken them down into all prime numbers. Now I need 3 of something to be able to pull 1 of them out. Now, does it matter if I do this 2, this 2, this 2, or this 2, this 2, this 2, or this 2, this 2, this 2? Absolutely not. You just need the pair of 3. So I can take 1, 2 out. Now, I don't have 3 of anything else in here. So 2 times that 3 times that 2 are still left in. So 2 root 12 was the actual final answer. Actually, I almost am making a mistake. When the index in the original problem is here, this 3, the index also needs to be in your ending problem. It needs to be the same index in the beginning of the problem and the end. Nice. All right, let me move this. This one's a little bit trickier, a little bit harder problem here. We're gonna nail it. So it's harder because it has these variables, these letters in it as well. But you just do the same thing that we've been doing. So 120, when I think of 120, I think of 12 and 10. Break that down to 2 and 6, 2 and 3. 10 can go to 2 and 5. And then when I have the letters, I actually just write out the letters so I can see clearly what the pairs are. So x to the 4th, that's 4 x's. Y to the 3rd, that's 3 y's. And then z's just chilling. So now everything's broken down the most that it can. B. Now I need 3 of something to be able to pull 1 out. So, I have 3 2's, so I can pull out a 2. I have 3 x's, so I can pull out an x. And I have 3 y's, so I can pull out a y. So when in doubt, write it out. And then what's left? Let's see, that 3 and that 5, so 15. That x and that z. So the final answer, we'd end up writing 2xy root, cube root, excuse me, because the index is 3. So my answer has to keep that index. Forgot it right there. It's the #1 mistake. I'm obviously almost making it. 15xz. Woohoo! So that is the simplified version of that radical. Now, where we're headed, you won't need to know how to do these just yet, but it's useful for you being the mathematician that you are. So that's how you break down radicals. Now, these last 3 examples, holy buckets. What is crazy different about those?